after this talk. And also, after lunch, we have Coffee Wars and Hardware Hacking Village. And if you wanted to do any contesting, most of the contests have already begun, so get to it. And now I'd like to introduce Chris Schafer, who's going to be speaking on tracking and blocking malware distribution with automation. Give him a warm round of applause.
Thank you. All right. So yeah, we're going to be talking about just what he said, malware distribution. We're going to talk about malware distribution networks, et cetera. But to start off, let's talk about who am I. Chris Schafer. I've been blue team all my life. Started at WRCCDC, came into the workforce from there. And pretty much my entire time I've been focused on automation. Automation's been kind of the lifeblood of everything I do. I get very frustrated doing the same thing twice. So my end goal is to never have to do the same thing twice. Automation plays right into that. See if I can make this work as remote. And then I also do kind of development. So initially I would never have said I was a developer, and then I saw code that other developers wrote, and I was like, oh, maybe what I'm writing is okay. It's not good, but it's at least okay. And then the thing that's also a common misconception with this is I'm not really a malware researcher. I'm on a malware research team at work, but I'm tasked with automation. So when I come in with all these insights about the threat actors and things like that, most of that's driven by their research. They're the really smart guys that have figured this out, and then they give me the information, and I use that to automate against it. Small disclaimer to start off with. You know, this is going to be dealing with malware. There's always risks when you use malware. Don't double click, you know, the basics. I'm also probably not going to be publishing all of my slides and you know, the code that I'm going to be showing you in this online. We do use it actively to deobfuscate and beat the threat actor, and I don't really want to make it really public how I'm doing that because I don't want them to change. That's a lot of work. Let's talk about what we're going to see in this talk. First, we're going to talk about the behavior of the malware distribution network. We're going to talk about how does that work. I'm going to provide some. It's all kind of guesses, right? I'm not on the team of the malware of the threat actors, so I can't tell you for a fact. But there's going to be a lot of guesses. We're going to talk about how we're going to leverage that to collect the malware. I'm going to show you guys how to analyze some initial dropper documents. We're going to talk about how we're going to analyze stage 2 payloads. And don't worry about these terminologies. I'm going to go over them in a second. And then I'm going to do a live exercise where I'm going to show you how you can write a deobfuscator for some common techniques. So let's lead off with like, what's an MDN? What's a malware distribution network? When I Google this, all I get is a bunch of academic papers and stuff that you have to sign up online to even view. So I kind of came up with my own definition. I said it's just a set of compromised servers that are used to host malware to get to targets, right? It's them going out, compromising a bunch of stuff so that they can get the malware into your organization. So now that we've kind of defined that, how do they use it? What does it look like from our side as a blue teamer? So pretty much this whole talk, it's going to be me focusing on Emotet because they're a very effective malware distribution network, and they're very common. Almost everybody deals with it. And it always starts, with a malicious email campaign for these. It's usually a URL, though they can also attach the doc file directly. It doesn't make a big difference here. But if it's a URL, it goes to the user. For the initial payload, it gets to a stage 2 payload and a C2. So let's talk about the initial payload. So the delivery here, the users received a URL via email. It's usually directly in the URL, but it could also be inside of like a PDF or something like that. They go in, they open it up, it says, you've got a new invoice. You need to pay this quick. And people, that scares people, right? You don't want to go into debt. So people get phished, they click on it, and they get a doc. So what the MDN really wants here, we need to talk about their goals. They want to get those users to click. They don't want to have their domains blocked. They want these clicks to actually get out there. They don't want to get blocked by your proxy. They don't want to get taken down. And they don't want to get blocked by AV on the document. So when they do download this document, they don't want that to get triggered by AV. So what do they do to do this? The first thing that's really obvious is they compromise a bunch of sites, right? They've got not just one site, but I'm showing 4 here. That's really hundreds per day that they're compromising. Where do they get these sites? Well, mass scan and WP scan, right? The WordPress sites are all over the net, and vulnerable WordPress sites make up like 80% of them. So they just go around, compromise WordPress sites, add that in on the email, shoot it off, and now they can deliver some malware. They also go to these sites that they've compromised, and they go host new malware pretty regularly on them to make sure that your AV isn't going to hash block it. We're going to go more into depth in that in a few minutes. So now it looks like this, right? We've got our side, and we're talking about the malicious actor's side on the top. Let's talk about the stage 2. So on the stage 2, it's that document. That document, when somebody opens it up, it's executing a macro, something similar. It's reaching out, grabbing an exe, which is then run on this system. It could be either an exe directly. Sometimes they do shellcode and they load it into a process in memory. But I don't see that as often just because it's a bit more difficult to do. And honestly, this is so effective for them. Why make their lives harder? And then this piece of malware here at the end, is often what ends up connecting to the command and control servers. So let's talk again about what their goals are. Their goals here is they want to infect this box, obviously, right? That's their big goal. They want to infect the box and reach out to the C2s. And in order to do that, they need to evade the antivirus on the system, both at the document and at the malware. They have to avoid any web blocks. They don't want your document to try to call out, and then they got blocked by the proxy, and they go, oh, shucks, we had 2 sites that they had a chance to block. And same thing for takedowns. What if that site gets taken down? That doesn't help them. But then they also kind of want to avoid collection. They don't want you to be able to get all of the EXEs that they're hosting. So how do they accomplish this? They have that document configured with more than one site. So say you clicked on that document, you executed the macro, and the first site, you saw somebody call out to it. Somebody else was infected. So you blocked it. Well, it tries the first one. It doesn't get an EXE down. So it goes and tries the second one, a third one. And on Emotet, it's usually even 5 URLs. And then they do the same thing for hosting new EXEs. So you can see here the scheduled upload. And they rehost new EXEs pretty frequently. And what they're doing, it's a concept called packing. It's pretty common in the malware world. And what they do is they take their EXE, and it's basically a loader. It's a piece of code that takes their encrypted EXE, decrypts it, and loads it into memory. So they repack this in a ton of ways, so it generates a new hash every time, right? They encrypt it with a new key. They encrypt it tons of different ways. And it means that you can't be hash blocked very easily. And unfortunately, some packers like UPX are even used for legitimate reasons, like I think it's Pi2exe, the Python to executable creator, uses these packers just to make itself a self-contained binary that, I don't know if it's a lazy thing, a compression thing, but I know it's an annoying thing. So now we're at this point. We've kind of got a bit of a view on their network, and we got a bit of a view on ours. So now let's talk about what they're actually doing for this building. What are they building, and why do they rebuild new documents that they're hosting on this initial payload that they're doing the scheduled file upload? So it looks confusing, but what they're doing here is they're hosting new documents pretty regularly, distributing them. They might distribute 60 documents in a day or have a new one. So if you download that site, You get one document, you download it 15 minutes later, you've got a different document. And that's constantly happening. And beyond that, these documents that they're hosting are reaching out to different stage 2 URLs. And as we started to do this and we started to download these documents, I would basically set it, they have a cron job uploading, I have a cron job downloading. As we download these documents and we look at what URLs they're configured to reach out to, we saw like at this time of day, it switches to a new set of URLs. At this time, it was like 8 a.m. to noon, noon to 4. I didn't put time zones there because those numbers aren't accurate, but it's just as an example. That they would reach out to different stage 2 payloads, which was really interesting to see the level of automation that they have on their side. And the same thing happened on the stage 2s, that they hosted new EXCs pretty regularly that were configured to go to different command and control servers. And at specific times of the day, you would see it switch to a new set of command and control servers. So we have all this information. Let's pretend we even downloaded these docs. What can we do with this? What's enabling us? So as I talked about, we start analyzing these initial payloads. We start analyzing all these documents so that we can get to these stage 2s and get a list of these stage 2s and figure out, how many documents today hit these stage 2s. We're trying to gain better insights on the threat actor. So how often are they switching? How many are they compromising a day? How effective have they been? And how long are they leaving these active? So one thing that's been pretty interesting is if they compromise a WordPress site, they'll distribute new documents, of course, until it's patched, or sometimes like after 3 days, they stop uploading new documents. And my guesswork on that is that they figured out that it's not effective after those 3 days. So 3 days after they've sent out an email with that URL, they've gotten all the clicks they're going to get. And at that point, they're just offering new malware to malware researchers, so they didn't want to make it too easy to collect them. So when you know that they're aging servers out like that, you can do some other tricks to get around it. Actually, I should have talked about this on an earlier slide. But on this, so now say you've got a document, and you know that there's other sites out there that are hosting that document. And you want to get them too, right? Because you want to have this self-feeding algorithm. You want to have it collect documents, go back, find new URLs, collect documents from new URLs, and just feed the cycle. So one of the big tricks that I used for that is I used Virus Total Intelligence, which will let you look up a document hash, and they'll show you other websites that were submitted that resulted in that same document hash. So using that, you'd have a set of URLs, you'd have a set of documents, and from those documents, you could go out there, find new URLs, and feed this loop so you have a constant stream of initial payload sites, and the initial documents. And then as you analyze these documents, they're going to reach out to different payload sites, the stage 2 sites. So now you have a list of stage 2 sites that you can go out and you can download the malware. So now you have the docs, you have the initial URLs, you're comfortable there, you've got a lot of data. What do you do with it? You need to start processing the docs. It's macros. It's document macros. You have to figure out how to process those macros. They usually use obfuscation, PowerShell invoke obfuscation. And if you look at their techniques, they change techniques about once a week on a minor basis, and then once a month they have a larger scale change. It's almost like they have weekly code reviews and weekly and monthly sprints. Like if you think about them as a development team, you can pretty much time their execution based on that. So let's take a look at one of these document macros. So it's a bit small on the screen, but it looks kind of garbage, right? Like that's a lot of work to process. And I don't really know how round works in VBA, stuff like that. And I looked at this and I said, that's too much work. I'll just try to do it dynamically. And then I looked at it a little harder, and I kept waiting, kept trying to figure out what was happening. And I noticed these areas. For those that can't see the screen, it's a string assignment for a /C, and then lower down it's a string assignment for POW%. And then I went and I was like, okay, well, where are they calling these strings? And they end up calling the strings with create object, and then just adding all the strings together, and then a run. So I said, okay, well, it sounds like all these strings just being added together. What happens if I add them together? And even, lucky for me, they put them in order in the document, so I didn't even have to rearrange them. So I wrote a short piece of code there. Can't see it on the screen. All it's doing is it's finding all of the strings in the document, concatenating them together, and this next slide is going to be even worse on this screen. Yeah, you can't read that at all. Yeah, it's a screenshot. I can't do anything about it. But what this ended up being a PowerShell line that did NetWeb client, and it just had a list of URLs and said call out to them, download them, and if the file had a PE header, execute it. If it didn't have the PE header, move on and download the next URL. So this is how we started to process these documents in bulk. I'm going to give a live example at the end of the talk on this, so you guys can watch me screw up there. But that's how we started doing these. So now we have documents, we have payloads, we have payload EXEs. The last step to monitor the infection chain is to get those C2s. So it's pretty much cheating how you do it. If you look at Cape, don't know if people are familiar with Cape. If you're familiar with Cuckoo, it's pretty much Cuckoo extended. Somebody took Cuckoo, the Cuckoo sandbox, which is a dynamic malware analysis tool, meaning that it executes the malware and it looks at what's actually occurring while it executes. And they took this and added their own modules on top. So they have, this on the screen, garbage. It ends up being YAR rules that are parsing out sections of memory that they figured out is how Emotet configures their C2s. And then say this stops working, usually they push an update in a day or two, and then you can back process a bunch of old ones. So now you've got all this data. You've got URLs that lead to doc files. You've got doc files that lead to payload URLs. You've got payload URLs that lead to EXEs, and EXEs that lead to C2s. How is this useful for your organization? How is this useful for you as a daily threat hunter or somebody responding to these campaigns? So what I did internally is I just span up a site. So whenever we would get an email delivered with a document or a URL that went to a document hash, you could plug in the document hash and immediately get the payload URLs. You could start enabling your team to have that analysis really quick so they could find the indicators to see if, did the infection continue or did it stop here? And you can do the same thing for payloads to C2s, right? You put in a payload hash, you can get a list of C2s. And this enables the teams to respond to these, high priority incidents much quicker. And then also because, I work in corporate, you get to do metrics. So on the metrics on this, we can start tracking, how many document URLs are we seeing per day? How many different documents? And when we saw this, we got to start identifying when there were spikes, when they started maybe doing a new campaign that might be more effective. We started, this level of tracking let us anticipate the threat actor a lot faster. And yeah, it ended up driving change, internally. Like we said, oh, well, this week they're not changing. They're not doing anything new. We can focus on other malware families. Okay, something changed. We saw a spike, like here. Nice spike. What they actually started doing is they started posting different payloads per document much more frequently. And we said, why is this happening? What's occurring? And it helped us understand the threat actor a lot better. The other thing that we started being able to do is we mapped the RSA keys to C2s. So if anyone's familiar with Emotet, they've probably heard of Epoch 1 and Epoch 2, which is the idea that they have two separate distribution networks. I like to call them dev and prod because you actually see them do testing on one, and then if it works, they deploy it to the other. And this sort of information really helps you decide, what's the effective way to deal with this. So this is a network graph. The red is RSA keys that the EXEs have been compiled with, mapped to the C2s that they call out to. And you can see that if a EXE was compiled with, one RSA key versus another, you never had a cross-contamination. You never had a C2 that was available in both networks, which was a really interesting thing to prove. Like, people kind of had figured it out, but then we started having, visual explanations of how it was occurring. And there's some non-visual things you can do too, right? You can start blocking these internally. You can start creating network indicators. Maybe you didn't catch the email getting delivered, but now you have a list of all the URLs that Emotet used today. And when you create a network indicator, you can head off an infection before it really happens. There are some more things I'd like to do with my system that I've written, but I haven't yet. If y'all are familiar with Emotet, what they do is they infect a machine. They're pretty much infection as a service for other malware authors. They infect a machine, and then they offer online, and they say, okay, who wants to distribute, 500 customers costs, $800. Who wants to pay $800 to distribute their malware on 500 machines? And so you can see all this different malware deployed with Emotet. If we start monitoring these C2s and actually joining them, we could see those modules getting pushed down. Maybe hurt their profit margins a little bit, because it's a little less effective to infect a honeypot. And then also to start tracking these techniques. As they use different techniques in obfuscation, I would love to map those to the files that occurred on so that I can see over time, this is how often they're changing, this is when they made big changes, and start being able to have more insight into what they're thinking, why they're thinking it, and when they're thinking it. Like, after DerbyCon, invoke obfuscation and invoke obfuscation occurred 2 weeks later. Like, they were like, oh, that was an excellent talk. Let's implement that technique. And, it was a pain because, there weren't good deobfuscators. So let's say you want to set this up. You said, this sounds pretty easy. And honestly, most of it is. I want to set it up. How do I handle it? The hard parts for me was the volume. I'm downloading a ton of files per day, and I'm expected to analyze all of them. So that meant that I could either do automated deobfuscation, which is static parsing. I don't hit a dynamic thing that maybe takes 5 minutes to analyze the doc, and it's not necessary to do static if you want to use Cuckoo or Kate sometimes, but here, I'll show you real quick why this isn't necessarily super effective. So, let me make sure I have the right one up. Okay. Here's a document. We're going to actually analyze the same document in a minute. That I turned network off, right? Because I didn't want it to download from the first URL and give up on the rest. And even on this analysis, when it doesn't have the network, you only get the domains. And you don't really get the full path. So you're like, okay, well, what if I could just get to the final PowerShell? I think that's under behavioral. You get this, which, it's nice, right? You got your execution, and you're like, okay, well, I know it's called PowerShell, and you get the useless PowerShell. They figured out how to make it not appear in there. So in these cases, you don't get to hit that in the same way. So the next step, so now what I'm going to do, give me a second. So now I'm going to turn my mirroring back on, and I'm going to show you guys an example of the deobfuscation techniques you can use, because it always seems very terrifying. It seems terrifying to get into doing deobfuscation, but it really isn't as bad as people think. So we're going to start with this document. Let's see. Let me zoom that in a little, and I'll make this full screen. All right. So this document, this is an Emotet document distributed earlier this year. Let me get here. So we can see it's this F2D. It was distributed actually November 2018. And here it is down here, composite V2 document. So when we want to look at this document, the first thing I want to look at is, okay, let me put this at the top, is I want to see the macro. So there's a good set of tools called OLE tools that lets you get into this. So if I go into OLE VBA and just honestly do it, sorry, OLE VBA 3, I'm in Python 3. We can see the macro. Yeah. Is that better? Okay. So up here, if you look at this, this is actually a really short macro. And we can see that it's doing this VBA shell, and it's calling this text frame. It's obviously, so I shouldn't say obviously. When you've dealt with documents a lot, you can see that this is calling text that's not present in the macro, it's present in another area. So this is usually where I would dive into browsing the different sections within it. So sounds intimidating, it's not that bad. So those are the different sections, and I think it's OLE browse. Yep, right here. Sorry for the size, I can do this. But these are the different sections within the document, and you can pretty much browse through them to view them. So let me swipe back over here. So we can see the size of them. We know that it needs to be a larger size. It can't be like 114 bytes. That doesn't work. So we're going to start looking at these bigger ones. We have table. I would avoid data because I hate the big ones. And then we're going to kind of keep going through and find the right area to execute. So in table, we go into the hex view, and honestly, it just looks like garbage. Right? I don't see anything here that looks like a command string. So, okay, back. And I'm going to cheat. I'm going to go straight to the one I know it's in. It's in the Word document. When we browse this Word document, we find a command. So now we bring that into the program, which isn't that bad. Sounds terrible. It's not bad, I swear. So we're going to use OLE tools again. So import OLE tools.vba, OLE VBA 3. I'm actually going to import the specific one I know. So VBA parser loads it in and lets me start accessing pieces of it. So if I do that over here, let me make that a bit bigger for y'all in the back too. So if I do a VBA parser of that file, it gives me an OLE object. So I'm going to cheat a bit, go directly to the function that I know will let me open that stream, but I can go OLE file.openStream, the Word document. And it's like a file, so I have to do a read. And I get all these bytes. Right, it looks scary, right? We've got a ton of bytes on screen. The color scheme's terrible, and it's not necessarily useful. Let me see if I can fix that color scheme. Yeah, red on black wasn't the right choice. If anyone knows how to do this off the top of their head, that would be fantastic. It's on what? Shell. And view. What's up? Shell, I don't. Yes. Appearance and. Oh no. I'll move this over to PyCharm, which I can restyle a lot easier. Is that readable? All right. So VBA parser. from OA tools. Sorry. I have a cheat file, so if I start to run closer on time, I'll start cheating. All right, so I think it's that. So now we have the doc file here, and we have my word variable, which looks like this. It looks like a bunch of bytes. But if you looked at it, it started with CMD, so I could start cheating and grab it where it starts with CMD. So the start would be, word.lower, because they might not capitalize it, they might go either way. And the end is where they have 3 new lines in a row. So I do the same thing, word.lower, index, 3 new lines, and it's byte. And then I want to grab that after it occurs in the start. And then I will have my command string equals that word, start. So let's look at what command string looks like if I do this. So here's a command string, and that's what we're looking for, right? We were looking for that CMD, and it cuts it off, but we'll get over it. And it goes till the end. So when we look at this command string, we need to first start dealing with PowerShell, right? We see methods of PowerShell obfuscation here. This is a substitution string. So what that means is where you see a 1, or like you see 6 here, out of this array, it picks the 6th variable and it just puts it in place. So we need to just start parsing through that. And then also later in the string, which and let's see, I want to decode this. Later in the string, I wonder if I can turn on wrapping. I don't know. Later in the string, it'll do a substitution with a char. It's here, string char 39. So what char is going to do is it's going to take that, if you're familiar with ASCII codes, it's going to take the ASCII code of that and replace it with the letter. So that's the first thing I want to do. I want to get my thing to strings that I can read as fast as I can. So first, I cheated a bit, and I compiled my regex, because it's no fun to watch me write regex on stage. And I look for a char with the digit afterwards, and I capture that digit. So I'm going to find that first. So for hit in regex characters, .find iter on that command string. Each one of these times, I want to replace that char with what it should be. So the number would be the first group. The full string, the thing I want to replace, would be the entire thing, which is group 0 in Python. And then, right, I want to actually get my character. It's a character, it's the same thing as them. Their char is CHR here. But then I need to do an integer because I don't want to interpret that as a string. It's an integer of that number. And then I want to replace that in my command string. The full string with my character. So let's also print what's happening here. Print replacing with that. And now when we run this, we can see it replaced char 39 with a single quote. So that's the first step. Now I have it as a string, and I need to deal with this -f operator, which if I can copy out of here. Oh, goodness. Is about, we'll go that far. I'll put that in a comment up here to make our life easier. easier was relative. So what we need to do here is we need to capture this first group into a string so that we could do that replacement. And then we need to get all the values that it's going to be replacing and parse them too. So the technique I use for this, I have a regex up here that does this. Because I'm tighter on time, I'm not going to explain it in depth, but pretty much it's just capturing that first group into one, all these digits. And then it captures, oh here, I got terrible. And then it captures the second group into another capture group. It's just so you get them as two strings out of this. So for hit in regex substitution, find iter, same thing. In the command string, the list of the format string, the thing that we want to format it with, is the first group. The replacement is that second group. And then also I want to get rid of any open-closed parens because when it captures it, it could capture both these parens and I don't want them. And then I want to come up with, what did they use to split that? So if we scroll way over here, sorry, if you're motion sick, don't look at the screen right now. When we see over here, they're separated with a single quote, comma, single quote. And we need to split that up so that we can get them all as individual things in our array. So to figure that out, I'm just going to look after the dash F and say, what's the first character? Because I know that they use that throughout. So my split character can actually just be the first character in that array. So that's replacement 0. And then the strings that I want would be that group, this replacement group. I'm skipping the first and last character because I'm going to be splitting on them. It'll make sense in a second. So that's excluding the first and last character, and then split on my split character, comma, my split character. And then I format that with, the split character. So let's look at what that's going to replace us with. So we have the format string, and then we have the my string. So let's make sure that got parsed out correct. So we've got the format string here, and we've got a list of strings to replace it with. So now let's actually do that replacement. And we say the new string is the replacement format with star my string. So what star does in Python is it takes that array, and say you have 3 operators, right? I want to replace it with string 0, string 1, string 2. When I put that star, it automatically expands the array into being the operators. You can read the Python docs on that to have it make more sense than me explaining. And then I want to replace that in the command string, right? Command string equals command string dot replace, and then the full thing, right? Hit that group 0. I want to replace the full thing with, I actually want to put a single quotes around it, format the new string. So let's see what that looks like if we do that. Oh, we had an error, and because of time, I'm going to cheat and I'm going to grab the right function. Actually, over here. I swear it worked yesterday when I was watching it. Okay, so now it's done that replacement, and we have this new string down here, which honestly isn't as bad, all right? This starts to make sense. Set this to this. We've got some junk here, but this is suddenly a much shorter string. And then if we look at the end of it, they start doing replaces. So we have, replace AB3 with $sign. It's hard to see on this screen, I know. but that's a big one. We need to start doing these replaces. So we just come up with a quick function to do the replaces. I'm going to copy paste that, but it's the same thing. Regex to grab the replaces and process it. And if we do those same replaces, now we have what looks like legitimate PowerShell. Here, let me see if I can copy paste this up here. There we go. And view wrap. I'm going to copy paste this into Sublime. I give up. Because I know I can do this. All right. So now what we have is we're having it do a base 64 string, decompress it, and for every item in there, it didn't decode this half, but that doesn't matter. But it's going to run whatever is in this base 64 string. So now we just have to decode the base 64 and look at that. That's pretty standard in PowerShell. You'll find Python functions online to do that all the time. I'm going to copy paste it from over here. I, of course, have to import base 64 and zlib. And we'll run this. And we have this, which I'm going to move over to Sublime again, sorry. Which this, I can handle this PowerShell. I can read this. I can come up with a parser for this. We see the NetWeb client with a set of URLs split with the @ sign. And then for each one of these, try downloading the file. And then if it, after it downloads it, invoke this DMT function that they wrote in the other. But what I'm looking for is these URLs. I found the URLs. I've gotten to them. So now I need to parse those URLs out. That's going to be super easy. I'm going to look over here. So I grab a single quote, or I'll paste this in over there where it's bigger first. I start with a single quote HTTP. I grab that as my start of the string. The end of the string is the next single quote. I split it on an @ symbol. So if we run this, we have the list of URLs in an array. So this is kind of an obfuscator, but you know, I wrote it for one function. How does that doesn't help. It actually does, because as long as you attack the techniques rather than attack the individual one, you can go in and you can start grabbing different pieces of malware they wrote. So here, we're going to try it on another malware hash I have. And so remember, down here we have this set of URLs. I'm going to put it in a comment at the bottom. If we run it again on a different hash, we get a different set of URLs. So as long as you're attacking the techniques, you can actually come up with the obfuscators for these things pretty much using regex and loop iterations a lot easier than you would think. Now, I know that when I initially brought this up at work, we thought that it wasn't going to work for very long, but it's only requiring about 15 minutes of tweaking a week, maybe an hour, and then when they do a larger change, about once for about an hour every month. The obfuscators, when you're dealing with mass packers, when they're automating, you can automate too. You can automate to try to take down their stuff. So I went kind of fast through that, but let me bring up this. So first, I want to ask questions. I know I went fast through a lot of areas. I kind of have a habit of talking around areas that I don't know as well. So any questions I could answer about what went on this? Cool. I either talked really well or really poorly. Mm-hmm. Oh, so automating on blocking for us is we start taking controls that we have in the enterprise. So say you have a proxy, say you have an IDS, and we take these indicators that we're generating here with the automation against malware network, and we submit them to that as it detects them. That will have to be tailored to your environment. But if you have an EDR solution that lets you feed bad domains, if you have a proxy that you can submit blocks on, you kind of have to tailor it to your enterprise, but you can do it. Cool. All right. So that was automating with automating yes malware. Oh yes. So one of the most interesting things for me has been figuring out just how convoluted the Word doc standard is. One of the reasons I didn't reverse the one for this week is we had to write a custom Office form parser because none of the public tools are doing it correctly. And you know, it's amazing that something so convoluted is used everywhere, right? Like the amount of stuff you can hide in a Word document is staggering. But then, yeah, they've also done some. It's also interesting because as you automate against them, you gain some insights. And I swear they're running metrics on their side to decide if their techniques are good or not. Because they'll do some things that I'm like, oh my God, this is hard to beat. Like they started on these URLs, they made it so when you hit it, it ran JavaScript and set a cookie and reloaded the page. So if you were getting the URLs, it didn't work anymore. They switched back from that like a week and a half later. And I was like, that was incredibly effective. Why would they do that? And I bet that they just were running metrics and they said, our infection numbers went down. We're going to revert that change. Cool. Well, thank you all so much.
Okay, as mentioned before, we have lunch right now. And join us back here at 1 o'clock for Fotis Chance talking about network exploitation of IoT ecosystems. Also, right now in Lockpicking Village is an intro to lockpicking. See you in an hour.